Well, good morning, good afternoon, everyone. Welcome into another exciting Exploring by the Seat of Your Pants broadcast. For those of you who might be joining us for the first time, we are all about bringing conservation, science, and adventure into classrooms around the world. Sorry, I've done so many of these today, my voice is tripping over itself. You are catching us on a very exciting day because we are in the midst of not only World Ocean Week, in which we have like 20 programs this week, but it is also Canadian Environment Week. So we've got amazing scientists from coast to coast to coast across the entire country featuring stories of fresh water, air, climate, fire, more. We've done 2 in a row to start off the day. I've been really thrilled to have colleagues at Jasper National Park talking about wildfire. Kiana Bear Hetherington just talked about her amazing work with Two-Eyed Seeing. And we are wrapping up my hosting today in style with Chris Derksen. He is with Environment and Climate Change Canada, and he is going to talk today about measuring snow and ice. His work has him go to some of the most remote places on planet Earth to take some of the coolest science on planet Earth. And we're catching him at a very exciting time because when I reached out to him for this week to come back on and do a broadcast, he said, I can only do it early in the week because I'm off to Greenland on another epic expedition. So if there's a cooler place to be going than Greenland to do climate research, I don't know where it is. And so I'm so thrilled to get the chance to bring back Chris to blow your mind with all the cool stuff he gets to do. Chris, welcome back to the broadcast, man. Thank you so much for joining us today, and take us away.
Thanks a lot for the introduction, Jesse. I hope everybody can hear me okay. Just let me know if you can't. And welcome to all of you. Thanks for joining. And again, thanks to Jesse for the great intro. Yeah, so my name's Chris. I'm a research scientist in the Climate Research Division of Environment and Climate Change Canada. And I'm talking to you today from my office in Toronto. And I'm going to talk to you a little bit about the work that I've been lucky enough to do over the years, measuring snow and ice in the Arctic. All right, base here in my office, but I also lead a research team that's focused on using satellite data. So we have satellites orbiting the Earth, taking imagery of the planet, and we use this data to help us understand how the Arctic is changing, how snow and sea ice is changing across the Arctic, what climate change is doing to drive or to force that change, and then how we have to adapt to it. But really, the favorite part of my job is getting out into the field, making measurements on the ground that ensure that we are interpreting the satellite data correctly. So this is a photo from a few years ago now near a place called Eureka in the high Canadian Arctic, one of my favorite places to go. We found this really cool piece of really thick old ice that had drifted and frozen in to the bay outside Eureka, and that's me and some of my colleagues on our trip there. So I'll show you a bunch of photos today, talk to you a little bit about the kind of work that I do, and at the end, if you have some questions for me, I'll be happy to discuss things a little bit further. So let's talk about snow and ice. How did I get involved in Arctic research in the first place? Well, I have to say I dug this photo out of the archives. This is me as well, quite some years ago now, I have to say. I always really enjoyed playing in the snow. And I was really fascinated reading about explorers moving through the Arctic and the Antarctic. And this is me with, I guess, some sort of very rudimentary snow fort that I had attempted to build. Quite a bit of work with that shovel. I think my dad might have helped me a bit too, to be honest, but not the best of snow forts, but I always had this real interest in spending time in the snow. And then my first trip to the Arctic was way back in 1994 when I was a student in university. I had the good fortune to meet a professor there who was running some Arctic field programs. And so I was able to go and live in this orange tent on the sea ice for about 3 months in the summer of 1994. And that really turned out to be a really influential trip in my life. I had such a great time. I learned an incredible amount, met some really fascinating people. And so I was lucky enough after 1994 to continue to find opportunities to do research in the North, to visit the Arctic. And I've been going back about, I guess, 25 times or so since then. And as Jesse mentioned, I've been lucky enough to be able to go to Greenland, where I've never been to Greenland before, but I'll be heading there next. So my work involves really getting out on the land, traveling around different parts of the Arctic and measuring the snow and ice. So this is kind of how we travel oftentimes. We'll have this line of people on snowmobiles, scientists on snow machines, bringing a lot of gear with us because, as I'll show you, sometimes we bring a camp with us, and we have to bring a lot of scientific instruments with us, fuel and food. And so really it's quite an effort, but such a fantastic landscape to be able to travel and work with my colleagues. So I spend my whole life working in snow, digging in snow, thinking about snow. And I thought I would take just a couple of seconds to talk a little bit about why, to me at least, I think snow is a material on the earth that's really super interesting. And actually, as for humans, it's like really important as well. Let's think about snow for a second. Maybe it's hard to think about snow right now. Looking at my window, it's nice and sunny and warm here. But, anyways, let's transport ourselves back into winter. And remember that snow is really important because when it melts, it provides fresh water. So across most of Canada, a lot of the water that we use comes from snow that is melted. So that's super important. Snow is also really bright. So when you've been outside in the snow in winter, helps to have some sunglasses on. What that means, or the reason why snow is bright, is it's reflecting energy from the sun, hits the snow, bounces back into space. So what does this do? Well, it means that snow helps keep our planet cool. It has a cooling influence on the global climate system. So that's really important. Snow is also a good insulator. So if you put snow on the ground, the soil stays a lot warmer than it would be in the winter if there was no snow on top of it. So for microbes and lots of other little things that live and process things in the soil, it's really helpful to have that warm layer of snow over top. And it explains why igloos, for instance, can be so warm because snow is really good at trapping heat and keeping cold air on the other side. Animals, caribou, Arctic hare, lots of animals live on snow, and some animals actually live in the snow. So it's really important habitat as well. And we're concerned more and more with what's happening with snow because it's pretty clear that snow responds very directly to climate change, to global warming. As our planet's getting warmer, we're seeing less snow on the surface for a shorter amount of time every year. So we're tracking very closely how and why snow cover is changing because of climate change. So some things to think about. Again, it's hard when there's no snow on the ground right now, but when you walk in the snow, is it the same depth everywhere? Well, it's not. Snow blows around. What makes snow move? Well, the wind makes snow move. So we always get snow blowing across the landscape. What makes snow stop moving? Well, maybe it hits some vegetation like a shrub or a tree, or in this photo here, you see snow being deposited in these really big drifts. So I always like this photo because here on top of this little basin here, there's exposed ground. There's no snow at all. But if you were to walk about 20 meters over here into this big drift area, the snow is 10, maybe even 20 meters deep. So all the snow in this whole area, a lot of it's blown into this area here. So snow varies a lot on the landscape, and it means we have to work extra hard in the field to make sure we're capturing the spatial differences that we see in snow as it moves across the landscape. So, getting into even a bit more detail, when you dig in the snow, are snow crystals always the same shape? Well, we know that no two snowflakes are alike, but once the snow is on the ground, it also starts to change. It evolves. So, what happens to snow as it sits on the ground? Well, typically you get a temperature gradient in the snowpack. Maybe you get a melt and a refreeze event. Maybe you get the effect of more wind blowing and scouring that top snow. So, as the snow sits on the ground, it metamorphoses. I think that's the word. It changes its shape, it changes its size, and so it's really a dynamic material during the winter as well. So, well, I love these photos. These are zoomed in, like almost microscopic photos of different types of snow grains. And so the question I'm posing here is which photo is the newest snow and which photo is the oldest snow? And I think it's pretty clear that in the top left of your screen here, these are classic fresh snowflakes. So they have this stellar dendrite, we call them. So they have these nice arms, that classic snowflake shape. But as that snow sits on the surface and it gets maybe blown around a little bit by wind, it starts to break apart. So now you can see what we call decomposed snow here. So you can still see the nice arms, the particles of snow, but they're starting to change their shape. After a little bit more time, they tend to round off. So now all those little points and needles, they've disappeared, and all you see are rounded shapes. And then finally, if the snow sits on the ground for long enough, and it's allowed to metamorphose for a long enough period of time, you get these cup shapes. And I'll show you a photo that I took in the field a little bit later that looks quite similar to this. So this is about the size of my thumbnail, some of these snow grains. They get really, really big. So you start with these really classic snowflakes, and after a few months, you end up with these large cup shapes. So really interesting evolution of the snowpack, which happens during the winter. So where have I been across the Arctic? Well, I've been lucky enough to get to all sorts of places in the Eastern Arctic, the high Arctic, and the Western Arctic across Canada. You can see the red line on this map. So I'm down here in Toronto. The red line on this map shows approximately where there's no more forest anymore, where the tree line is. So all my visits have been north of the tree line. So we're dealing with wide open tundra spaces. And you can see, Canada is a really big country. And so that's why we rely on information from satellites to help us track the snow cover. Because if we tried to do it from the ground, it would be really hard. We just simply don't have enough observations to cover such a large country. So we use satellites and we get out there on the land every once in a while to make sure we're interpreting the satellite data correctly. So I thought now what I do is just show you a series of photos, a series of slides that gives you a sense of how we live and the kind of work we do when we go into our field camp. So this is an example of a field camp where I used to go every year for quite a few years near a place called Daring Lake. And we would fly in a small airplane like this. We had snowmobiles there to help us move around, and we could stay in tents like this. So kind of like when I was camping on sea ice, kind of like a permanent camp that we can fly into every year. Pretty comfortable and really a great place to work. But sometimes we take the camp with us. So this was part of a trip I did with some colleagues, some friends from Alaska, where we traveled quite a long distance across the Canadian Arctic, and we would bring our tents and our food and our fuel and everything with us. We were towing sleds behind our snowmobiles. Every night we'd set up camp and we'd make snow measurements. And the next day we would travel and stop and make measurements and travel again. So it was really a cool way to make measurements across a large area of the Arctic. So this is kind of my favorite way to travel. We still do some trips like this. So super cool that we can basically bring everything with us that we need to survive on the land. And we get lucky enough at night to see some really cool things like this. So that's the moon looking really bright, and that's a planet. I think it was Venus, but I can't remember exactly. And that's sort of what our tents look like at night on a nice, cold, clear Arctic night. You can see just a hint of northern lights maybe on the top left if your screen is clear enough. It's just quite faint in that photo. I really like this photo because this is the outside of the tent. It looks nice and peaceful and calm. When you're inside the tent, well, it's pretty crowded. So you can see that's me lying down on a cot here. You can just see a head over here. One of my colleagues, and actually a third person, sleeps in behind the heater over here. And we have a lot of gear with us. So the main point from this slide is it gets a little funky in these tents. You have 3 people living in close quarters, drying out all of our gear. We have boot liners, so our feet have been in these all day. It gets a little musty. So I have to say it helps a lot when you're traveling and working with your friends, people that you're very comfortable with, because you have to spend a lot of time in very close quarters together. This is another site in the Western Canadian Arctic where I was just a couple of years ago. And at night, we each got our own little small Eureka tent to sleep in. You had to dig your way in, dig the snow out, and we could each sleep by ourselves, in this case, in our own tent. Really nice and cold, about -30. So we have a nice sleeping bag, really great place to sleep. And there were some bigger tents at this camp where we could cook our food and do some of our research. I really like this is a sunset photo here. So how do we travel? I mentioned snowmobiles. We spend a lot of our time driving over the land in snowmobiles, and we bring sleds with us. And in this case, we're going on a really long trip. So you can see we have a lot of gasoline with us, a lot of fuel to keep our snow machines running, but also we have scientific equipment, our tents, our sleeping bags, our clothes, our food. So everything we bring with us when we travel across the land. Sometimes we come across some pretty tricky features to navigate across. This is on, I think it's Great Bear Lake actually, but this is my colleague named Glenn who's nursing his big snowmobile over a ridge of ice. So you can see this big ridge here, quite chunky, but we made it. We made it through that. This is a photo again that just shows traveling across the land by snowmobile. Really a fun way to travel. This is in Eureka in the Central Arctic again, the high Arctic. I like this shot because it's me with my goggles and hat on, looking down at some of my colleagues, checking some instruments down here, and you can see our tracks where we came from before we took this photo. Sometimes we work by helicopter. So this is a kind of a cool photo, lots of blowing snow and a really cool kind of cloudy day. So when we have longer distances to travel or we have to move a bit more quickly, we can travel by helicopter and move from research site to research site. This is some helicopter sampling we did again in the high Arctic. These are the Sawtooth Mountains on Ellesmere Island in the background here. And I always felt bad for a helicopter pilot on these days because it was really cold and he had to sit there and wait for us in the helicopter while we did our snow measurements. Luckily for him, it was a sunny day, so I think the sun kind of helped keep him warm in his helicopter. But I love this photo, really cool backdrop of the mountains. So what do we do? What are we actually measuring when we're out working in the snow? I like this photo because it shows a kind of a cool contraption we have. This looks like kind of like a ski pole, and this person's wearing a backpack, and you can see this backpack is connected by a cable to the ski pole. This is kind of an ingenious device that some colleagues in the US invented that helps us measure snow depth automatically. Snow depth is not that hard to measure. You stick a ruler in the snow and you see how deep it is, those numbers down. So what they devised was a little basket that you can't quite see, but it rides up and down this pole. So it sits on top of the snow surface. And then that basket is, that tells you how deep the snow is. And there's a global positioning. So with one press of a button, we get a snow depth and we have a location where we made.
Oh, Chris, your mic just is muted. Sorry, it's come disconnected for a sec. Take a second, all good. We were good up till then. Hasn't been for long. Let's see. It's literally come unconnected, so it might be the headset. Your presentation's still going well. I'll put it in the background. We sort it out. All good. Something should go a little wrong, otherwise it's no fun. You can type me in the private chat if you need me. We're gonna get. Oh, Chris, I think you're good. You're back.
Back.
You're
Okay.
back.
Let me go back to sharing my screen.
Perfect. Thanks, man. Sorry for the trouble.
Technology.
Oh,
Okay.
yes.
Can you see my? Can you
We
see
can
everything
see
now?
it, and I'll let you know when it's gone to absolute full screen. Perfect. Yes, you're good to go. If you want to drag that little banner off, perfect. You couldn't be better. Let's do.
Okay. So sorry about that glitch, but here we are measuring sea ice. So we're measuring how thick the sea ice is. And you can see the way we do that is by drilling a hole in the ice. And just to give you a sense of how thick the ice can grow in the Arctic, this is what the auger, the ice auger we used to drill looks like before we start drilling the hole. We have to stand on the snowmobile to get high enough to get the drill started. And then after some pretty hard work, we punch through the ice into the water, and then we can measure how thick the ice is. So if we ever get cold, a good job to volunteer for when we're in the Arctic is to be the person who has to drill the hole, because that gets you nice and toasty warm again. So you can see pretty thick, couple of meters thick ice at this site. We also look very closely at the snow grains. So what shape are the grains? What size are they? This is really important for helping us interpret the satellite data. So here's me staring through a field microscope to get a sense of what the snow grains look like. And this is one of those pups or faceted grains that I showed you earlier from the other photograph. This is one that I took, and you can see there's some fresh snow that made it onto the card here where I took the photo. And this is a big, really big snow grain that's about, 6 millimeters by 6 millimeters. So yeah, that's pretty big as one of my fingernails. We sometimes put instruments on aircraft. So here we have an aircraft flying low, has some instrumentation on it that we use. We can compare what the aircraft measures to what the satellite measures to what we measure on the ground. So we can do things at different scales. This was a fun project where we camped out and had an aircraft flying with us. And then sometimes we work at places where we have weather stations. This is a weather station in the Western Canadian Arctic, measures precipitation, energy from the sun, all sorts of different things. And we can really use that to help us interpret our data as well. So what are some of the interesting things we see? Well, I think wildlife is one of the main things that I find fascinating in the Arctic. So I'll show you a few photos here of some of the interesting things we see. These birds are called ptarmigan. They're kind of like Arctic pigeons. They're very well camouflaged. So then they move around in really large groups. So they're pretty cool birds, and because they're always moving in groups, they leave these really interesting footprints. So I think sometimes ptarmigan forget that they can fly, and so they walk very slowly, kind of waddling through the snow, and they leave these really cool patterns of footprints across the snowpack. I really like this photo because it's kind of interesting phenomenon that we see. So why do we have these circles of snow on this bare ice? That seems kind of unusual. But what happened here was a large animal, probably a bear, walked on the ice when there was snow on top, and the weight of the animal compressed the snow. And then the got windy, and the wind came and blew away all the light snow, the uncompressed snow that was around this. And what you're left with is essentially like backwards footprints, right? So these are the footprints of the animal on the snow that made the snow a little bit denser, so it was able to withstand the effects of wind. So really a cool phenomenon that we don't see very often in the Arctic. This is Arctic hare. We see lots of bunnies. Um, they're very fun to watch. This is an action photo of an Arctic hare being chased by a gyrfalcon, which is a type of bird, predatory bird in the Arctic. We were quite fascinated to watch this chase go on for quite some time, and I'm happy to report that at least while we were watching, the bunny managed to evade the bird. So it's the story has a happy ending, at least for the bunny. Wasn't caught in this case. We see a lot of caribou, so they travel in large herds and they move across the Arctic, foraging for their feed through the snow. So caribou really are quite concerned about snow as well. And these are maybe my favorite animals to see. So when we were on Ellesmere Island, there were a lot of muskox in the area. So they have really cool horns and like kind of a skull on the outside of their head, really cool fur. And what's interesting about muskox is when they feel a little bit threatened, they'll stand in a circle, a defensive circle. So they all face outwards. They put their young in the center for protection, and all the muskox form like a protective circle. So what that makes for is really nice photographs. We of course leave them alone. We don't get as too close. But when you have a good lens on your camera, you can get great photos like this. So muskox are very cool animals. Sometimes we see just bizarre things. I don't really know how to explain this one. We saw a spider one time that just popped out of the snow. I had no idea there were spiders where you would find snow, but apparently in this case there was. We also, well, in this case, we saw these bear tracks, so pretty big bear tracks in the snow here. And then not too long, we came across this deposit, which in case you're wondering what this is, that's some bear poop. So sometimes we see some really interesting things like that when we're in the Arctic. Northern lights, we see this really cool phenomena in the sky when it gets dark at night. If there's a lot of solar activity, and actually the last month or two, there's been some amazing northern lights visible across Canada, even in southern parts of the country. But these are some photos that of some really cool northern lights. This one reminds me a bit of a donut. Call that our donut northern lights. What else do we have here? Oh yeah, this one's cool. Looks like a ghost kind of in the sky. I think we were camping with some elders from an Inuit community. They built an igloo and came and camped with us to help keep us company. That was really cool. And we had some amazing northern lights while they were staying with us. This is called a sundog. So I'm not sure if you can see it on your screen, but my colleague here, he's blocking the sun with his head. So we have the sun in behind him here. And then you can see like a halo effect where it kind of looks like there's twin suns, one over on the right side and one over on the left side with kind of a rainbow effect. So this is created when the atmosphere is very cold and there's ice crystals in the high atmosphere. It creates this kind of halo effect that's called a sundog. And this was a really good sundog because you can actually see three suns, which I think is pretty cool. So that's a rundown really of what I wanted to show you today. Photos of the work that I'm lucky enough to get to do across the Arctic, measuring snow and ice. But this program is called Exploring by the Seat of Your Pants, which is, it's a phenomenal program. And I thought, let's finish by just talking a little bit more about exploring. What makes someone an explorer? And I think we all can be explorers in our own way because there's some simple things we can do, some simple choices we can make in how we lead our lives that kind of make us all kind of explore things. And what I have found in my time in the Arctic, at least, is that sometimes it's nice to do things that push you out of your comfort zone. It's okay to be cold. It's okay to be away from home and maybe a little bit nervous about the environment that you're living and working in. So I feel like it's okay to be a little adventurous, get out of what you find comfortable. if you find something that you're really interested in, throw your energy into that, focus on that, really try to find something you're passionate about, because that really helps make school interesting, helps make life interesting if you have topics or hobbies, that you're really, really keen on. Share what you've learned with other people. Don't be afraid to go out and talk to people, listen to people. Really helps to share our ideas and listen to each other. And finally, maybe one of the most important lessons for me, at least, is I've included a couple photos here. This is one of my colleagues whose name is Arvids, and this is another one of my colleagues whose name is Matthew. And they're a bit older than me, and they've spent a ton of time in the Arctic. They're excellent snow scientists, both of them, and they have taught me an incredible amount about how to travel in the north, how to make scientific measurements in the north. And to be honest, I could include 50 more photos of different people who currently live in the north or have lived in the north or have done work in the north, who have been incredibly helpful to me. So really try to find that mentor, or you as well can support others who have similar interests to yourself. So that's my pitch for what makes an explorer. And I hope you found my stories and photos interesting today. And I'm happy to take any questions or comments that you might have. So I will stop sharing now, Jesse, so I can see everybody
Perfect.
better. And thanks again for joining.
Thank you so much, Chris. That was spectacular as always. Such a pleasure having you, and I'm so excited for your upcoming expedition. Before we went live, Chris and I were talking about the fact that once he's back from Greenland, we'll have to have him on in the new school year in September to feature some new pictures and update his truly spectacular program. But as you mentioned, we're going to dive in with Q&A. YouTubers, please feel free to share in the chat. We'd love to hear from you. One of our first ones goes back to your Northern Lights thing. So how often do you see Northern Lights when you're up there? Is it every day? Does it depend on the season? If you could explain a little bit more about that. That was I got to see them here in Newfoundland recently, so it's a big focus of a lot of Canadians right now.
Yeah, absolutely, Jesse. Yeah, it's really a special thing to see. It doesn't happen all the time. You need the right combination of a clear atmosphere. So you can't have clouds, obviously. So you have to be able to see out into space. And you need to have the right solar activity. So I'm not an expert on this phenomenon. I like to look at it, but I don't know that much about it. But you need some magnetic particles that are ejected kind of from our sun, and they interact with the magnetosphere, which is like this outer part of the atmosphere, and they create those patterns, and they're always moving. So they're kind of wavy patterns in the atmosphere. They look fantastic. As Jesse said, we've been really lucky the last couple of months. There's been some really big solar events that have led to northern lights being seen further south than you normally see them. So if you're lucky to be in the right place at the right time, they're pretty cool to see.
Yeah, fantastic. We're gonna go to one online. By the way, speaking of fantastic, sorry, like we've got tons of time for Q&A. I got to see the aurora. I actually went for my honeymoon to Iceland, which is the staging area en route to Greenland for Chris, to see the Northern Lights. And the other day we had them over our house here in Newfoundland, better than we saw them on our trip. People saw them in Toronto and Vancouver. I hope all our audience got the chance to see them as far south as Missouri, California. I know saw them. Like it was a really wild show not too long ago, following right on the heels, by the way, of a total solar eclipse over much of North America as well. So it's been an exciting time for stargazers recently. Katie wants to
That's
know
right. Yeah.
why do you need to measure the ice? Is there any what's the general reason we're going out to do this measurement to begin with? Good.
Yeah, that's a great question. So the main sort of driver or motivation we have for doing this work is that like snow and ice is really important in the Arctic. It's important to people who live there, but it plays an important role, as I mentioned, in our climate system as well. And the really key thing is that we know that climate change, the general warming of temperatures across the planet, is having a real impact on the thickness of the ice, the duration. So when it forms in the fall, when it melts in the spring, how much snow is falling, where and when it's falling. And so we need to really understand what those changes are and how quickly they're happening. And a really important reason as to why we need to understand those changes is, a lot of people across Canada, we get our water from snowmelt. So the snow melts in the spring, we use that water as it melts during the summer. And an important complement to the snowmelt is glaciers in the mountains in Western Canada. So glaciers melt slowly all summer and then they accumulate fresh snow during the winter. But what's happening is that they're losing more ice in the summer than they're gaining during the winter. That's called having a negative mass balance. And when a glacier has a negative mass balance, it means it's slowly dying. And so in Western Canada, we know that our glaciers will mostly be gone, certainly by the end of the century. So all will be old, but or gone, but the glaciers will no longer exist. And so we need to think about how we can most effectively use snow as a water resource to help replace the water that we'll lose when that ice melts. So there's really a lot of different reasons for different people why we care about snow and ice. But I think water is kind of one of the main things. We all need water. We all, ecosystems need water. Humans need water. And so when we think about changing water resources, that's one of the main drivers of our work.
Chris, we had a question about your Greenland expedition. How long are you going? What are you doing up there? Are you hopping around the whole country or what? What's going on?
That that's a great question. So we're working with colleagues from Denmark, who have a network of weather stations that are spread all across the ice sheet. So Greenland is most of the island of Greenland is covered by an ice sheet that in some places is kilometers thick. So really, really thick ice. And they monitor the weather conditions across the entire ice sheet by having a network of surface sites where they measure wind speed, precipitation, snow depth, all the sorts of things you want to measure at a weather station. But because Greenland is so remote, they set these sites up and then they have to leave them and then come back and visit them only once a year. So I'm part of a group that's going to go and visit these weather stations, replace the batteries, replace any broken instruments, just do some basic maintenance, make sure the weather stations are still working. And then what we're also interested in is how much fresh snow fell over the previous winter. So it's June now. So June in Greenland means it's getting into the melt season, but it hasn't started to melt quite yet. So we'll be able to make measurements of the snow depth and figure out how much snow fell from last fall. And we have some instruments that we use at Environment Canada that are pretty cool instruments for kind of measuring how deep the snow is and what the vertical properties of the snowpack are. So we're going to share those instruments with our Niche colleagues and collaborate with them, work together, and then they're going to see if they really like these instruments, they might buy some for themselves. So it's a really good way for scientists from different countries to work together to share the instruments we have and work together in the field. So yeah, that's I'm super lucky to get to go.
Very cool. I'm so happy for you. I hope it goes marvelously. And for any of our students that don't want to wait to hear about some cool Greenland expeditions, I will highly recommend Arctic Ascent on Disney Plus. It's amazing and features a whole team of scientists traversing around a really, really special place. So very, very cool. Chris, we got a question about you. You highlighted your first expedition. How old were you when you first went up to the Arctic? What was we saw some pictures, but how old were you?
Yeah, well, let me think. I think I was 20 years old, 19 or 20. So I was a University of Waterloo co-op student. So co-op students mean you take school for 4 months and then you go do some work for 4 months and then come back to school. And when you try to get your first job, I was pretty young. I didn't have any experience, so it's pretty hard to get a job. So luckily I ran into this professor who I was taking a course from and was learning a lot from, and I knew he was doing work in the Arctic, and I was fascinated with the Arctic. So I just kind of said, "Hey, is there any way I could ever get involved in your research?" And he said, "Well, actually, I'm hiring a field assistant right now." And so that just turned into a really lucky
Cool.
break for me, and that led to so many different things. So yeah, so don't be afraid to ask people questions. It's a lesson I learned from
Gonna
that one.
say that's a big lesson we get from a lot of our speakers. It's quite amazing if you just ask for information. Like most scientists, most people in these amazing roles that we get to feature at Exploring by the Seat of Your Pants are so keen to share their understanding, as you mentioned in your explorer sort of key things. And it's amazing what roles will come from that. So 1920 is very early to get that sort of opportunity. And we just had a person who's just out of university. Like you do not need to be a seasoned, grizzled old veteran to be going on these things. You can make those opportunities for yourself, and it can lead to an epic career having some of the coolest adventures on planet Earth. So great answer, Chris. That was great, man. Time flies and you're having fun, and we need to let you get off to Greenland pretty soon. So I'm going to leave with one final note. Is there
All
any
right.
last message you want to share with our audience today about your work, about the Arctic, anything to wrap us up before we say farewell? No pressure.
Oh, yeah, you're putting me on the spot. But yeah, I would just say again, it's I've been very lucky to go to the Canadian Arctic. It's if you can read about it, think about it, understand how climate change is impacting Canadians who live in the Arctic. It's a major challenge for them. And also, we often say, what happens in the Arctic doesn't stay in the Arctic. So the climate change impacts we're seeing in the Arctic, for many different reasons, they will impact all of us across Canada. So, climate change is a significant challenge. It's a challenge certainly for our friends who live in the north, but it's a challenge for all of us. And so our hope, is that we can all work together to both understand the impacts of climate change and reduce the magnitude of the impacts of climate change. So if we just keep that in mind, think about how we're leading our lives, that can be really helpful for everybody. So I hope that helps a little bit. And thanks everybody for listening in today.
No better message than that. Thank you so much, Chris, for joining us today. I want to encourage all our classes, check out our Environment Week slate of programs. We've got so many more to come in the next few days amidst an, in general, 30-plus program week at Exploring by the Seat of Your Pants. So much to explore from some of the coolest scientists and storytellers on planet Earth. Chris, we'll wrap up there. Thank you so much for joining again. Have a wonderful expedition, and we'll